Sanjay.
Yeah. No doubts, no? Okay, let us quickly do the question answers. So how do we convert kilometer per hour into meter per second?
Five upon 18.
Kilometer per hour into meter per second. Yes, multiply with 5 upon 18. And meter per second into kilometer per hour?
18 upon 5.
18 upon 5. Okay. Do question number 5 of the numerical. Question number 5, have we done?
In this, we have to convert the speed into meter per second.
No need, because time is also in hour, and this and the speed unit is also kilometer per hour. So you can get the distance in kilometers.
But I have taken
Because then you have to convert it into seconds, so it will be very tedious. So 65 into 3. Done. Sixth one. A car travels first 30 kilometers with a uniform speed of 60 kilometers per hour, and then next 30 kilometers with a uniform speed of 40 kilometers per hour. So you find out the time in hours, how much time in the first half and how much time in the second half. And then you find the total time. Okay. And then you can find the total speed, average speed, total distance upon total time.
first we will do 60 upon 30.
Correct. Then 30 upon 60. Huh?
30 upon 60 and then 30 upon 40. Then we will
Correct.
take out the time and then
Yes.
add the total.
Yes.
total time is coming 1.25 hours.
How much time did you get?
1.25.
1.25. 1 hour, 25 minutes.
Yes.
So it cannot be 1.25.
It is coming in decimal.
Yeah, so how are you getting 1.25? So you have first half, so you have 30 kilometers upon 60, so you get half hour, right? And then the next one, you are getting 30 kilometers upon 40, so it is 3/4 hours. So in total, you get 1.5.
0.5 and 0.7.
So 2 plus 3 upon 4. So 5/4 hours, right?
Because I have, yes.
This is what you get. Yeah. So then total distance, 60. Total time, 5/4 hours. Therefore, average speed,
Total distance, total time.
distance upon time. So 48 kilometers per hour. Okay. Okay, question number 7.
First one is 80 kilometer per hour.
How much did you get?
80 kilometer per hour.
Okay. And second one?
Second one,
What is average velocity? Displacement upon time taken. What is the displacement?
there is no displacement given.
Displacement is 0 because it is traveling from station A to station A back.
Yes.
So the displacement is 0.
So the average velocity will be also.
Correct. The average velocity is also 0. Question number 8.
speed is equal to distance upon time. So distance is 1 kilometer. We will convert it into meters, so it will be 1,000 meters. So 1,000 upon 100.
Correct. So that you got. And then velocity. Only you have to put the direction.
Velocity. Oh. Yes.
You have to just put the direction, correct?
Yes.
Okay. Last one, then remaining you can do as homework. Question number 14.
9, 10, 11, 12 is a 13 is homework.
Yeah. The remaining you can do as homework because they are of same type. So let us do question number 14.
The formula is
Initial velocity is given.
and final velocity is not given. So it will be we will take final velocity minus initial velocity upon the time and is equal to acceleration.
-2, okay? Because this
Yes,
is
retardation.
yes.
Final velocity is 10.
Correct. Okay. So today you complete this. Okay. And just let us go through the question answers also. The objective ones, you can even mark them in the book itself. The subjective ones, like when is the body said to be at rest, this all definitions are already given with they are with you in the PDF as well. So motion in one dimension, displacement, unit, differentiate between distance and displacement, all these are given. So you make a note of it. If you are taking the printout of the PDF, then you can mark there itself in the PDF. Okay, so you complete this. So as soon as we complete the chapter, we'll put up the test. And if you have any doubts, then you can ask me tomorrow. Okay. So now we'll move to the second part.
In the second part, acceleration time graph is cut.
Acceleration. Okay, fine. So then today we can complete the second part. Then it is very easy. So motion in dimension, part B. So in one-dimensional motion, the direction does not change. This is what we have seen, the rectilinear motion along a straight line path. So since it is a straight line path, the direction is not changing. And since the direction is not changing, the displacement and distance remain the same. The graphs, distance and the displacement graph remain the same unless and until there is a change in direction. Okay, so one-dimensional motion, since the motion is along one direction, the displacement time graph and the distance time graph remain the same. Displacement is always taken along the y-axis and time is taken along the x-axis. Displacement is taken along y-axis and time is taken along x-axis. The slope of the graph gives us the velocity. The slope of the graph gives us the velocity. Positive slope, there can be negative slope as well. So the positive slope is the slope where the body is moving away from the starting point. So when the graph is going in upward direction, the slope is positive. When the graph is coming in downward direction, then the slope is negative. When the body is returning to the starting point, then the slope is negative. Okay, so one-dimensional motion, why we don't have separate graphs for one-dimensional motion? Because the direction does not change and hence the distance and the displacement graphs are same. Okay, so when we say displacement time graph, then displacement time graph means what? The displacement is taken along the y-axis and the time is taken along the x-axis. And the slope of the graph, how do we get the slope? The slope is given by perpendicular upon the base. So the slope of the graph that is perpendicular upon base . The slope of the graph gives us the velocity. Now, positive slope, when the body is moving away from the starting point. So this is a positive slope. And when the body is coming back, returning to the starting point. Suppose it went from here to here, and now it is coming back. So this is positive and this is negative.
Coming down, so it means retardation.
Yes, it is coming down. Okay, so it is the retardation. Clear?
Yes.
Now, first graph, that is displacement time graph. When the graph is parallel to x-axis. So look at this graph. This line is parallel to x-axis. So when the graph is parallel to x-axis, that means the distance is not changing with the time. The distance of the body is not changing with the time. And this graph tells us that the body is stationary. It's not moving. And since the graph is parallel to time axis, there is no slope. Slope is 0. And so the velocity is 0. Okay? Slope is 0, hence the velocity is 0 because the body is not moving. So if the body is stationary, you cannot have slope, you cannot have velocity. Is this clear to you, Anya?
Yes.
Now the graph is inclined to time axis with uniform slope. This is the graph. So the velocity is given by perpendicular upon base, that is displacement upon time. Perpendicular is the displacement. Along the y-axis, we see the displacement. Along the x-axis, we have the time. So a truck is moving on a straight line path, is given direction with uniform speed. Displacement is directly proportional to time. The larger is the slope, the larger is the velocity. The larger is the slope, the larger is the velocity. Okay, if the graph had been like this, suppose. So it had covered 50 meters in 3.5 seconds, of 2.5 seconds, suppose. 2.5 seconds. So then the slope will change 50 upon 2.5. So it becomes how much? 20 meter per second. But at present, this graph is saying 50 meters in 5 seconds. So it becomes 10 meters per second. So the larger is the slope, the more is the velocity or speed. Since it is displacement time graph, so we will say velocity. Clear? This is another graph. Can you tell me what is the speed, or what is, oh, sorry, this is the velocity time. Okay, from displacement time graph, this is the displacement time graph, we will get the slope, and then we can get a velocity time graph. Okay, case 3. Now, when a ball is moving on a perfectly smooth surface, it is hitting the wall and coming back. So this ball is moving away, reaching a final destination, striking that end and coming back. Okay, so this is the positive graph, positive slope. This is the negative slope. So OA is the positive slope and OAB is the negative slope. In both the cases, the velocity is uniform. How can we say that uniform? Since you see 100 meters in 50 seconds, again 100 meters in 50 seconds. Look here. Final velocity, final speed, displacement 100, initial 0. So what is velocity for OA? 100 upon 50, so 2 meter S minus 1. What is the velocity along AB? It is 0 minus 100 upon 50, so minus 2 meter S minus 1. This is how we get the negative velocity. Negative velocity. Negative velocity.
Okay.
Okay. Now, displacement time graph for a body moving with variable velocity. Here, the body is moving with variable velocity. That means its velocity is changing. Displacement is not uniform with the time. So this is the displacement time graph. So it is a curve. It's not a uniform. Now, when this is the case, when the displacement time graph is a curve, so then the body is said to have variable velocity. Then how do we find the velocity at any point? So what we will do is that at that point, you draw a tangent and you get the slope of that tangent. So slope of the tangent at that particular point. This is not practically asked. It is just a theoretical question that how do you find the velocity velocity from a displacement time graph which is not uniform. So we get the tangent. So we draw the tangent and when they calculate the slope. This graph is not possible. Why? Because the time is not changing and the displacement is changing. So the body cannot be at two positions at the same time. You see, the time is fixed and displacement is changing, vertical up. So this is not possible. There should be one more. Okay, yeah. So coming back to displacement time graph, we had 4 types of graphs here. This one, what does it say? Displacement time graph?
Object is stationary.
Yes. Then the second one, we got this one. This says that the body is moving with uniform velocity. Uniform velocity. Then we saw this graph.
Retardation.
No, the body is going away from a point, coming back to the point. So this is positive velocity and this is
negative velocity.
We are not talking about the retardation because it is a displacement time graph. So from the slope of the displacement time graph, what do you get?
I2 minus Y1 upon X2 minus X1.
That is what?
Slope, the formula for calculating.
Yeah, so what do you get? What is that? Velocity. Slope of the graph, you get the velocity. This graph is not possible because a body cannot be at two positions at the same time. Time is not changing and the positions are changing. All clear, this part?
Yes.
This is the graph with the variable displacement, okay, not uniform displacement. Now, velocity time graph. So velocity is taken along the y-axis, time is taken along the x-axis, similar manner. And here the slope will give the change in velocity upon time. So that is equal to, this can be also written here, V2 minus V1 upon T2 minus T1 is also equal to Y2 minus Y1 upon X.
Same formula.
Same formula. But now the slope will give us the acceleration. So displacement time graph slope gave us velocity. Velocity time graph slope will give us acceleration.
Okay.
Okay. So we can have positive acceleration, we can have negative acceleration, that is retardation. So when the slope is moving away from the starting point, so that is the graph is moving away from the starting point, then it is the positive acceleration. And when the graph is returning to the starting point, then it is negative acceleration. Now here are two things we get. One is the slope that gives us the acceleration. The second is the area under the graph. The area under the graph between the time axis and the graph gives us the displacement. So from velocity time graph, if we take out slope, we get the acceleration. And from the velocity time graph, if we take out the area, we get the displacement. I repeat, from the velocity time graph, if you take out slope, then it is acceleration. From the velocity time graph, if you take out area under the graph, it gives you the displacement. Clear?
Yes.
So area above the time axis is positive and area below the time axis or under the time axis is negative. The total displacement is the arithmetic sum. We'll be doing with the help of a graph. The total displacement is arithmetic sum. Look here. This velocity time graph, the graph is parallel to the time axis. That means what? The velocity is not changing. Is body moving or not?
Yes.
Yes, the body is moving because that is why the body is having certain velocity. So body is not at rest, but the body is moving with uniform velocity. And since the body is moving with uniform velocity, the acceleration is zero. The acceleration is zero. Slope is zero, acceleration is zero. If you remove the initial point, see, let us take this one. Let us assume this is 20 meter per second. So V2 minus V1 upon time, that is equal to 20 minus 20 upon time, and that is equal to 0. So slope is 0. Let it be V1, let it be V2. So since it is constant, the slope is 0. And hence acceleration is 0. Now, if I've asked you what is the displacement, let us assume OC. Let us take C as, let us put here 30 seconds. So as we discussed earlier, the area under the graph will give you the displacement. So area under the graph, OC is 30, AO is 20. So length into breadth.
This is displacement and this is velocity. Acceleration.
Displacement. And the velocity is 20 meters, constant. And the acceleration is 0. Clear? Is the graph clear?
Yes.
Okay. Now, graph with positively inclined time axis. Positively inclined time axis. The initial velocity is 0. Final velocity is 10 meters per second. So the slope will be what? V minus 0 upon t. So 10 upon, let us take this is 5 seconds given here. So acceleration that is 10 minus 0 upon 5.
By 2.
Correct. (2 meters) s minus 2. Now, what is the displacement when it is moving from 0 to B? What 0 to A? What is the displacement?
Half into base into height as the triangle.
Huh?
It is making a triangle, so it will
Yes,
be
it
half
is making
into
a
base.
triangle. Yeah.
Half into base.
Half base into height, correct. लिखने का छोटा छोटा So area, how much did you find out? Displacement. Clear?
Yes.
Simple?
Yes.
So far, any complications? Now, the graph negatively inclined to the time axis. The body is coming to the starting point. So negatively inclined, the body is coming to the starting point. So this is U, this is V. Initial velocity is also as denoted by U.
Same formula.
Yes. So slope you will get. So let us put this one. Okay. 5 meters per second, and let's put the time 10 seconds here. So now what is the slope? What is the slope? Or what is the acceleration?
Acceleration will be 0 minus 25 up to 10.
Yes. So that is deceleration or retardation.
Displacement will be half 25 into 10.
Correct.
One 25.
Correct. Very good. So when the body comes back to the starting point, it will usually, the body was initially moving with the same velocity and finally comes to the rest, then the retardation is taking place. some velocity, yes. So the retardation. Now this graph is a special graph. Now here you have, see, till now the initial velocity or final velocity, at least one was 0. Here final was 0. In this case, initial u was 0, right? And we had v.
Yes.
And now in this graph, the body is moving with certain initial velocity. Let us take this as 5 meters per second. And let us take this as 25 meters per second. So the body is moving with some initial velocity, and that is u. And this is v.
So we will take 25 minus 25 minus 5 upon the time.
Yes. At this time be 5 seconds.
25 minus 5 upon 5.
Yes.
Meter per second.
So that is the acceleration. Now what is the displacement?
Displacement will be half into 20 into 5.
So parallel sides 5 and 25. So half into 5 plus 25. And the height is 5.
Half into 13.
Very good. Correct? So this graph tells us the body is having some initial velocity, so the body was not at rest. The more is the inclination or the slope, the more is the acceleration. Okay. Now this is the graph, then the body is moving with the variable velocity. It's a variable velocity. So we have to just identify whether the velocity is variable or not. We don't have to do any calculations with this kind of graph. Now look at this graph. The body was at rest from A to O. Body was at rest from A to B. It started increasing, moving, right? With certain velocity was increasing constantly. And then B to C, it was moving with a uniform velocity. And from C to D, it is retardation. A to B, acceleration. B to C, zero acceleration. C to D, retardation. Clear?
Yes.
With the displacement area of this figure. So if I say AO equals to, let's say, 20 seconds. And let us say BC equals to 12 seconds. And this perpendicular. So let us say the final velocity achieved is, let's say, 25 meters per second. So now what will be the displacement? Let us put these also.
Half into base into height. And we will take first AOB, then BC. We will take some numbering here. First, we'll take for two triangles and then for the big rectangle in the center.
Why, Anya? Can we take directly for the trapezium?
But it is a quadrangle.
There is a trapezium. Two parallel sides, and this we have the height. So area of trapezium.
Half into base.
Correct. Half into sum of the parallel sides. Into the height. So half into this lower one is 20. Okay. And the upper one is 12. And this is 25. Okay, whenever we have a trapezium, take the area of the trapezium. That is a faster method of calculation. Now let us find out the acceleration along the slope AB. Okay, let me put here. Acceleration along the slope AB. So it is 25 upon 2. So it is 12.5 meter S minus 2. Acceleration along BC is 0 upon 12. So it is 0. Acceleration along CD, it is 0 minus 25 upon 6. So that is equal to minus 25 upon 6 minus 1.
Where the 12 came from?
Okay. Look here. I've mentioned this one as 2. Okay. This part is 2. So
Yes.
from 2 to 14, so we get here 12.
But 2 plus 14, no, why 2 minus 14 minus
14 minus 2, ना? Time difference कितना है? यहाँ पे let us put here M and let us put here N. This is M and this is N. So what is the distance MN?
minus
14 minus 2. आया समझ में?
Yes.
And then the last one. This is 20 minus 40, so 6. Okay. Now I'll do this one. Find out, this is speed, so it is same as the velocity. Okay, so find out for each one. Find out the acceleration, of part A, of part B, of part C, and D. Then also find the displacement of part A, displacement of part B, displacement of part C, and displacement of part D. Quickly.
For all displacement, you will take half of the base height.
Yes. According to the figure you have to take.
Acceleration A, it will be 3/2 mls.
Correct.
For A acceleration B, 0.
Yes.
For acceleration C, 0. And for acceleration D, -5/4.
Acceleration D, 0.
Acceleration D is 5 -5.
No, C.
C is -5.4.
Why minus?
Because it will be 25 minus 15 upon 30 minus 2, so it will be 0.
So 25 minus 15 is 10, right?
Yes, and that the C is 0.
30 minus 20 is 10.
Yes, 0.
15 upon 10 is 1.5, beta.
It will be 10/10, no? Because
15 upon 10. Or 10 upon 10, sorry, 1 meter per second.
0
and
beta,
1 meter per second, na? 10
yes,
upon 10, 10 upon 10.
1 meter per second, and for acceleration D, -5.4.
25 upon 50, so minus 25 upon 50, so minus 5 upon 4. Correct. Now, displacement. Displacement of A.
Not done it, but it will be a half into 15 into 10.
Correct.
$75.
Yes. Second one. B.
Second one will be half into 15 to.
Oh, it is a rectangle. It's a rectangle.
So it will be 15 into 10.
Correct.
150 meters.
150. Next one.
And for C, it will be half into 20 into 10. 125 meters.
Yes. How much?
125 meters.
400 meters.
It will be half into 25 into 10.
25 plus 15, 40, so 200 meters. This is 15. This is 25. So 15 plus 25?
Yes.
40. 40 by 2, 20. 20 into 2, 20 into 10. Perpendicular distance is 10. So it becomes 200 meters. You can also find out the area of this rectangle. So it is 15 into 10, that is 150. And here half into 10 into 10, that is 50. So 200.
And for D, it is 250 meters.
250, correct. So now this you can do, right? These are the, so what is this blue graph telling?
Or retardation.
Yes. What is this green graph telling?
Uniform speed.
Uniform speed. what is uniform speed कैसे हुआ बेटा?
Velocity time graph. It is
velocity time graph, no?
Increasing velocity, uniform acceleration.
Correct, uniform acceleration. And what is this graph C?
It is uniform velocity.
Velocity, zero acceleration. Graph E.
Uniform acceleration.
But with an initial velocity.
Yes.
If you compare graph B and D, which one you will have more velocity?
Can you repeat?
Graph B and D, which will have more velocity?
More velocity. D.
Yes, more is the slope, the more is the velocity. Okay. When the body is moving in negative direction, losing speed. Okay, this I think you can do now. This will be the negative displacement, okay? Area of this triangle will be negative, area of this trapezium will be positive. And then total net displacement will be sum of this plus this. Okay, so stop here for physics. So, Anya, you will have to go through this and try and complete the numericals. Only the numerical part, theory part you will be able to do because we know almost everything we have written in the PDF is also sent to you. So numerical part you try and complete so that I can understand whether there is any problem or not. So if you have any issue, we can correct it tomorrow. So that second part. At least do 10 numericals. There are how many are there? There are 12. So at least you do alternate numericals you do, and if you don't have time, at most alternate numericals, so 6 to 8 numericals you should be able to complete. Then tomorrow is the most crucial part, that is part C, and these numericals are very, very important, and the derivation is also important for part C, so that we will be doing tomorrow. Okay, so quickly have a break. We are almost overdue. So 12:10, 12:55. Let's meet at 12:55.
Okay.